Hello student, and today we discuss about the theorem of real analysis. Prove that a monotony increasing sequence tends to its upper bound. Proof: let sequence n be a monotony increasing sequence whose least upper bound is capital M. Two cases arise. Number 1, M is finite, and number 2, M is infinite. When M is finite, by definition of least upper bound, sequence n is less than M for all n. Okay, that is equation 1. N plus epsilon is greater than M for at least one n. Let this be true for n equal to M. Then M plus epsilon is greater than M. That is, M is greater than M minus epsilon. That is equation 2. But the sequence is monotony increasing. Then n is greater than equal to M if n is greater than equal to M. That's form equation number 3. From equations 2 and 3, n is greater than M minus epsilon for all n is greater than equal to M. Again from equation 1, n is less than equal to M for all n, so n is less than M plus epsilon for all n, and hence also from n is greater than equal to M. Combining these, M minus epsilon is less than n is less than M plus epsilon for all n is greater than equal to M. Therefore, mod of n minus M is less than epsilon for n is greater than equal to M. Therefore, sequence n tends to M. When M is infinite, then from equations 2, M is greater than M minus epsilon equal to capital N, where capital N is arbitrarily large. But n is greater than equal to M is greater than n for n is greater than equal to M. Therefore, a sequence n tends to infinitive and so to the upper bound infinitive. So, hence the theorem.